Okay, let me give you two other examples for which the limit of f of x, x approaching a, does not exist. Such an example is, for example, the function f of x equals to 1 over x. So let me draw this function so that you see what happens. If x gets closer and closer to 0, then 1 over x gets larger and larger. For example, if x is 1 over a million, then f of x is a million. So the function looks on the positive side like that. And on the negative side, if x approaches 0 but being negative, then it's like 1 over negative 1 over a million is negative a million. So it looks like that. So in other words, at 0, the function explodes either in the plus infinity direction or in the minus infinity direction. So in that case, the limit of 1 over x, x approaching 0, does not exist. And even the limit for x from 0 plus of 1 over x does not exist in the sense no real number. And of course, similar, the limit for x going to 0 minus 1 over x also does not exist. But we can be more precise. More precisely, we can say that the limit for x approaching 0 plus of 1 over x is plus infinity. It grows bigger and bigger. And the limit of x going to 0 minus of 1 over x is minus infinity. So here's a little bit, I get this question a lot. Students say, well, what does it mean? Does it exist or does it not exist? Here I say the limit does not exist. And here I say the limit is equal to plus infinity. What is it now? Well, the limit does not exist as a real number. This is correct. But being more precise, the limit of x going to 0 plus is infinity, means it grows bigger and bigger, but not to a real number. It grows unbounded. So in this case, we say that f of x has a vertical asymptote at the point x equals to 0. Another example of a function for which the limit does not exist is the function f of x of sine of 1 over x, where x is not equal to 0. Now, the strange thing is this function stays bounded because the sine of something is always between minus 1 and 1. But the function doesn't approach a single number if x gets closer to 0. And the picture of this function looks very strange. It looks like sine, but then it gets, the wiggling gets bigger and bigger and looks like that. So what does, let's insert some numbers. So for f of x equals to sine of 1 over x. Let's say we put x equals to 1 over k times pi in there. So where k equals to 1, 2, 3, and so on. Then f of 1 over k of pi, well, it's sine of 1 over that, so it's sine of k pi, and this is always 0. So now every multiple, the sine of every integer multiple of pi is 0. Okay, fine. Now you might think, well, since 1 over k pi approaches 0, the sine of it is 0, so maybe the limit is 0. No, but now let me take another number. Let me take the numbers 1 over 2k pi plus 1/2 pi, where k is 1, 2, 3, and so on again. So in this case, we have f of 1 over 2k pi plus 1/2 pi is equal to sine, I take the reciprocal, 2k pi plus 1/2. Now, if you take an even number of pi and you add 1/2 of pi, the sign of it will be always 1. So think about, for example, 2 pi. And if I take an odd multiple of pi, and I'm adding 1/2 of pi, I get, if I take f of 1 over an odd number of pi plus 1/2 pi, take the reciprocal again, it's then sine of 2k plus 1 pi plus 1/2 pi. And then if you think about this, you get -1. So it's a really strange function. I have points which getting closer and closer to 0, but their function values are sometimes -1, sometimes +1, sometimes 0, and then everything in between also. So since the function does not approach a single value, we must say that the limit does not exist for that function.